All right, for section 8.5, we are looking at fun with word problems today. So this should be fairly brief. We're going to go through 4 examples together. But basically the idea is they're going to now describe a situation where our job is to create the right triangle that fits their description, right? And then from here, now I can use things like sine, cosine, and tangent in order to solve for whatever it is that they're asking me to find. There's 2 vocab words, though, that I want to introduce you to before we go through some problems, and that is an angle of depression and an angle of elevation, right? So here's kind of an image of an angle of elevation. So if you were standing here and looking upward, then the angle of your vision to the ground is called the angle of elevation. If you were standing at the top looking this direction, well, you have what we call the horizon straight in front of you, and then we have your line of sight looking down towards the ground. This creates your angle of depression. I want to try to give you an easier drawing, though. So take a look at this one. Let's go this way with it. Because here's a simpler drawing that I think will help you remember what's what. So I want to put them both together in one drawing. So again, if you were standing here and you were looking upward, then my angle of elevation is this guy. The common mistake that a lot of times people make is they want to say that this is the angle of depression, right? It's not. If you look at where the angle of depression is drawn, notice if this is my triangle, notice it's not drawn inside the triangle, right? It's drawn above it. So here's a good way of looking at it. So if I was standing at the top looking downward, this is my horizontal. Therefore, this is my angle of depression. So here's a couple helpful things for you on this. One thing is elevation and depression are always connected to a horizontal line, never a vertical line. That's why depression cannot go here, because I can't connect it to a vertical line. I need to connect it to a horizontal. So elevation and depression are always connected to a horizontal line. The other thing that we always should know about them is they're equal, right? If you look back, this line, because it's horizontal, is parallel to this line. That makes these guys alternate interior angles, which, as we've learned, are congruent. So do keep in mind that depression and elevation are always equal to each other. Okay, so let's see if we can draw some triangles here. Now on these ones, they've already kind of created the drawings for us, right? So, what I wanted you to see on this is they could easily not give you the drawings, and you would have to come up with your own drawing. Okay, and so let me show you that within this first one. So let's pretend that we don't have a drawing here. In fact, let me cover it up for a minute. So even if you have these printed out, pretend that you don't have the drawing for a minute. Let's see if we could draw our own. So if we said the angle of elevation from point A to the top of a hill. So here's point A, and I am looking to the top of a hill. So here's the top of the hill. Is 49 degrees. So remember, that has to be formed with a horizontal. So there's my 49 degrees. And it says that the point A is 400 feet from the base of the hill. So here's the bottom of the hill. Here's the top of the hill. So this one says that it's 400 feet from the base of the hill. So here's our drawing. So what are they trying to ask us to find? How high is the hill? So they are asking me for this guy. They're asking me for the height, right? So this is how we can come up with our own drawings if one isn't provided for us. Okay, now so they drew obviously a very similar one, but it's nice when they give it to you, but they don't have to give it to you. So it could be very likely that we're not looking at a picture, and we got to be able to do what we just did here and come up with our own. So where do we go from here? I'm now back to solving a right triangle, so I'm back to looking at SOHCAHTOA. So I'm going to say, okay, here's the angle that I know. I am working with the opposite leg and the adjacent leg, which I know is my tangent ratio. So I'm going to say the tangent of my angle is equal to opposite over adjacent and remember, before I go to the calculator, I always get x by itself first, so I would multiply the 400 over to the other side. Before I go to the calculator. So now I'm going to type this in. So it looks like the height of the hill would be about 460.1 feet. So there we go. So the only thing that's new about today's lesson is the drawing, right? So it's like if you can come up with the drawing, the rest is review. There's nothing new about this process that we're using to solve it. It's just a matter of making sure that we can identify the correct drawing if they don't give us one, right? Obviously, in a case like this, if they just tell you what the drawing is, then there's really nothing new to this lesson. So find the angle of elevation. So here's a right triangle. Remember, this would represent the angle of elevation to the sun when a 12.5 meter tall telephone pole casts an 18-foot shadow. So if we were drawing our own, a couple things that I would remember is, remember, a shadow would always lie on the ground. So I know that my horizontal is where I would put the shadow. And it also tells me that the telephone pole is 12.5 meters tall. So that represents a height, a vertical height of 12.5. Okay, and so we easily could have come up with our own drawing on this. So how do we find our missing angle? Well, from here, I'm looking at the opposite leg and the adjacent leg, which again is tangent. So the tangent of whatever angle that is opposite over adjacent. So there's our setup, and as you guys have learned in our previous lesson, whenever I'm looking for an angle, I know I need the inverse trig function to do it. So there's our setup. So that's what's going into the calculator. And there's our missing angle, so 34.8 degrees. All right, two more. And again, guys, I always kind of want you to do this from the lens of, what if they didn't give me the drawing? How would I draw it? Right, so when I see that a ski run is 1,000 yards long, well, think of a ski run. Ski is a slope, right? It goes down at an angle. Okay, and so I would be skiing down the hill like this for 1,000 yards. So that's why they made this slope right here 1,000 yards. Vertical drop, so vertical means straight up and down, is 208. So that's why the 208 went right there. And it says find the angle of depression. So remember, this is the angle of depression, not this. That's important. The other thing you should recognize, if this is my drawing, I don't really want to try to find an angle that's outside the triangle. I want to find an angle that's inside the triangle. So one of the things we set up above is, remember that depression and elevation are equal. So I could just as easily find this guy. And that would still equal my angle of depression, since elevation and depression are equal to each other. So now we're back to SOHCAHTOA. From this angle, I'm working with the opposite leg and the hypotenuse, which is my sine function. So I'm going to say the sine of x equals opposite over hypotenuse. Right back to an inverse trig function. So we're going to do the inverse sine of 208 over 1,000. And we have our angle, about 12 degrees. All right, last one. So from the top of a 120-foot high tower, so remember that 120 would describe the height of a tower, so I know that's my vertical. It's telling me that I have an angle of depression of 19. So even though they put it here, realistically, just like we did in the last problem, if I was drawing this, I would put that here because I know that elevation and depression are equal. So that's where I would put the 19. So how far from the base of the tower is the plane? So that's important. If they said how far from the top of the tower, that would be this line. But if they say how far from the base of the tower, it's going to be this line. So that's why this is our question mark. I'm just going to change that to an X. That's what we're trying to find. Let's set up our trig function. So from this angle, I'm looking at the opposite leg and the adjacent leg. So that is my tangent function. So the tangent of our angle, which we know is 19 degrees, is opposite over adjacent. So there's our setup. So if I just wanted to get x by itself, remember how we did this earlier, is you want to take this bottom piece and multiply it over to the other side so that it becomes x tan 19 equals 120. And now to get x by itself, I would divide this over to here. So in our calculator, we're going to have 20 divided by tangent of 19. So that's all we have to type in. So about 58.1 feet. And there we go. So guys, as you can see, not really nothing new in this assignment other than maybe coming up with your own drawing if they don't provide one. So definitely in the problems today, if they don't give you the diagram, really important that you draw it. In fact, even if they give it to you, I would redraw it on my own paper so that I can mark it, I can label it, and then that's going to help guide the setup that I use in solving. So make sure you show all your work for this like I did in the notes. But that is it for this one.